So dear students, in this video we will be discussing more about the problems on conservative vector fields. So let us move on to the problem section. So before that, let me discuss a note. So in the last class, we have dealt with what is it meant by a conservative vector field. So we said that a field F is said to be conservative if F can be represented as F is equal to gradient of some scalar function phi. If the vector field F can be represented as gradient of a scalar function, then F is conservative. And moreover, we have also discussed a conservative field test in which it was said that if F is equal to, if the vector field F was given by f of xy I plus g of xyj, it has only I and j components. The vector field F has only I component and j component, then F is conservative, then it satisfies the condition dou F by dou y is equal to dou g by dou x. So this was discussed in the earlier section. This note is just like a generalization of that particular concept. So if F is a vector field and F satisfies the condition, F is a vector field and F is given by f of x, y, z, I. That is, F depends on three variables x, y, and z. So F is given by f of x, y, z, I plus g of x, y, z, j plus h of x, y, z, k. Then if F is conservative, then F satisfies these conditions, these three conditions, and similarly, there is the conditions are dou F by dou y is equal to dou g by dou x, dou F by dou z equal to dou h by dou x, and dou g by dou z equal to dou h by dou y. And conversely, just like the previous result, if F satisfies all these conditions on a simply connected domain, then F is conservative. So this is just in fact a generalization of the previous result. So go through this result. This is very important. If you are given a three-dimensional vector field, this result was for two-dimensional vector field. So if the given vector field is three-dimensional, you have to use this result. And we can also observe that for a three-dimensional vector field, F is conservative, then F satisfies these three equations, and this is equivalent to the condition that curl F is equal to 0. So, in order to check whether F is conservative on a simply connected, on an open simply connected domain, we need only to check curl F, whether curl F is equal to 0 or not. So, that is our conclusion. So, let us move on to the problems. First example. So in this example, here we are given a vector field F. F is given by the vector field F is given by. It is clear that F is a three-dimensional vector field. F depends on x, y, and z. So F is given as yzi plus xzj plus xyk. This is our vector field. We have to determine whether the vector field F is conservative or not. So just by this particular result that we discussed now, if F is conservative, then curl F equal to 0, and conversely, if curl F equal to 0, then F will be conservative. So let us check whether curl F equal to 0 or not. So what is actually curl F? Curl of a vector field is given by the cross product del cross F. Fine. How will we compute the curl of a vector field? This is equal to actually the determinant of I, j, k, dou by dou x, dou by dou y, dou by dou z, and the components of F, yz, xz, and xy. This is the expression for curl of a vector field. So this is equal to I into dou by dou y of xy minus dou by dou z of dou by dou z of xz, dou by dou z of xz plus not plus, minus j into dou by dou x of j into dou by dou x of xy minus dou by dou z of yz plus k into dou by dou x of yz minus dou by dou y of yz. So this is the expression for the curl of f. So let us calculate each and every term. So what is dou by dou y of xy? The partial derivative of xy with respect to y. That is equal to x. So I into x minus dou by dou z of xz. Partial derivative of xz with respect to z. It is again x. So minus x minus j into dou by dou x of xy. Dou by dou x of xy is y minus what is dou by dou z of yz? It will be equal to again y plus k into what is dou by dou x of yz? It is equal to 0 minus dou by dou y of dou by it's here dou by dou, so that's a small mistake. So that was actually dou by dou x of xz. It was not yz. It was dou by dou x of xz. So here we have a small correction. It was actually not k into 0. It was let us write the correct expression. It was plus k into dou by dou x of xz is z minus what is dou by dou y of yz? It is again z. So what you obtain is that this is 0i plus 0j plus 0k. That is equal to 0. So you obtain that del cross f equal to 0. That is curl of is equal to 0 for this particular vector field. So you obtain that curl of equal to 0. Since curl of equal to 0, this implies that you will be always you will be giving a simply connected domain. So this implies that f is conservative. So we have obtained that f as a conservative vector field. That's about this problem. Now let us move on to another problem. So determine whether the vector field f is equal to 4 plus 2xyi plus x square plus 3y is conservative. So again, this is a vector field and here we can write this is a two-dimensional vector field. So it has only two components. F of xy is equal to 4 plus 2xy and g of xy is equal to x square plus 3y. These are the two components. What was the condition to check whether f is conservative or not? If f is conservative, by the conservative field test, we know that dou f by dou y will be equal to dou g by dou x. And similarly, the conversely, if dou f by dou y equal to dou g by dou x on a simply connected domain, then f will be conservative. So we need to check only whether dou f by dou y equal to dou g by dou x or not. So you take dou f by dou y, that is equal to dou by dou y of 4 plus 2xy. Dou by dou y of 4 plus 2xy. What is the partial derivative of 4 with respect to y? It is equal to 0 plus dou by dou y of 2xy. Partial derivative of 2xy with respect to y. It will be equal to 2x. So dou f by dou y is equal to 2x. That is our first thing. Now let us compute dou g by dou x. Dou g by dou x. Dou g by dou x. Dou g by dou x is given by dou by dou x of what is g? G is equal to x square plus 3y. What is dou by dou x of x square? It is equal to 2x plus dou by dou x of 3y. Dou by dou x of 3y is 0. So again dou g by dou x is equal to 2x. So you obtain that dou g by dou x is equal to 2x. So now you obtain that dou f by dou y is equal to dou g by dou x, and this means that the vector field, the given vector field f is conservative. F is conservative. Hope that this is clear to you. Now let us move on to the next problem. So again you are given a vector field. This vector field f is given as e raised to y I plus x e raised to y j. This is our vector field f. So let us write it. F is equal to e raised to y I plus x e raised to y j. So in the first question, you have to check whether the given vector field f is conservative or not. So it is on the xy plane, and here you are given a two-dimensional vector field. So since the entire xy plane is a simply open, simply connected domain, we need only to check whether dou f by dou y is equal to dou g by dou x or not. So in this question, what is our f of xy? The component of f in the direction, the x direction or in the I direction, it is equal to e raised to y. What is g of xy? G of xy is equal to x e raised to y. What is dou f by dou y? Dou f by dou y is in fact dou by dou y of e raised to y. This is equal to e raised to y. What will be dou g by dou x? This is equal to dou by dou x of x e raised to y. Dou by dou x of x e raised to y. So what is the partial derivative of x e raised to y with respect to x? It will be e raised to y. So what you obtained is that from here you obtain that dou f by dou y is same as dou g by dou x, and this implies that the given vector field f is conservative. F is conservative. So that is the first part. We are done with the first part. Now let us move on to the second part of this particular problem. In the second part, you are asked to find the scalar potential of f. So by scalar potential of f, what is the meaning of scalar potential of f? So for this, we know that since we have proved that the vector field f is conservative, there exists a scalar function, say phi, such that the vector field f is the gradient of this particular scalar function phi. That is, f is equal to gradient of phi. What do you mean by gradient of phi? This is equal to dou phi by dou x I plus dou phi by dou y j. Fine. We are restricting it with respect to j, with respect to I and j only, because f is the given function f is a two-dimensional vector field. Fine. So f is equal to del phi. This is equal to dou phi by dou xi plus dou phi by dou yj. But we know that the vector field f is given by e raised to yi plus x e raised to yj. This is our vector field F. So by scalar potential of F, it means that you have to find phi. You have to find the scalar function phi. So how will we deal with this particular problem? Since the left hand side of these two equations are the vector field F, we can equate these two equations by equating the components. Here dou phi by dou x is equal to e raised to y, and dou phi by dou y is equal to x e raised to y. We have done with these kinds of problems earlier. So what you need to do is that either how to obtain phi from dou phi by dou x or dou phi by dou y. So you have dou phi by dou x here. So in order to obtain the scalar function phi is actually a function of x and y, because this is a two-dimensional vector field. So in order to obtain the scalar function phi, you have to either integrate dou phi by dou x with respect to x or dou phi by dou y with respect to y. So let us integrating dou phi by dou x with respect to x. Dou phi by dou x with respect to x. Then what will be the output? Integral dou phi by dou x dx. This is equal to, what is dou phi by dou x? It is e raised to y. So this is integral e raised to y with respect to x. So in order to integrate e raised to y with respect to x, the functions of y will be treated as constants with respect to x. So you can take e raised to y outside, e raised to y into integral dx. This is equal to e raised to y into x plus, there will be a constant of integration, but since the function of y is treated as a constant with respect to x, the constant of integration will be a function of y. So integral dou phi by dou x, with respect to x, this is actually phi of xy. So now you obtain that phi of xy is equal to x e raised to y plus some function of y. Okay. Now we have to obtain this particular unknown k of y. So we have to obtain what is k of y. So for that you just differentiate equation number 1, with respect to y. So if you differentiate equation number 1 with respect to y, the output is dou phi by dou y, derivative of phi with respect to y. That is equal to dou by dou y of x e raised to y plus dou by dou y of k of y. This is equal to, what is dou by dou y of x e raised to y? So we can, while differentiating with respect to y, x can be treated as a constant. So this is equal to x into dou by dou y of e raised to y. That is equal to e raised to y plus the partial derivative of k of y with respect to y. That is equal to k dash of y, because k of y is a function of y only. So we obtain dou phi by dou y is equal to x e raised to y plus k dash of y. But by equation 2 we already know that dou phi by dou y is equal to x e raised to y. So if you write this as equation number 3, clubbing equation 2 and 3, you get x e raised to y is equal to x e raised to y plus k dash of y from equation 2 and 3. So cancelling the similar terms, you will obtain that k dash of y equal to 0. The derivative equal to 0, which means that k of y is a constant. Say some k of y is a constant. Say k. So what you obtain is that phi of xy, the scalar function phi of xy is given by x e raised to y plus k. So phi of xy is a function of the form x e raised to y plus k. So this is the answer for the This is the answer for the second problem. So we have found out the scalar potential of F. It is x e raised to y plus k. Now moving on to the third subpart of this particular question, we have to evaluate the work done by the field, vector field F, on this particular particle that moves along a semicircular path C from 1, 0 to minus 1, 0. So this question is also this question is actually meant to test whether you have actually understood the concept of a conservative vector field in terms of work done. We have already discussed in our earlier video that for a conservative, if F is conservative, if F is conservative, then it means that the work done, that is line integral over C F dot dr, is independent of path. That is, this particular line integral does not depend on the path of integration, or we have already proved that this particular line integral is actually clearly there will be some function such that f equal to gradient of f. Then to move a point from x naught y naught to x1 y1 along any curve C joining these 2 points, this particular work done will be nothing but the value of the scalar function phi at the value of the scalar function phi at x1 y1 at the terminal point minus the value of the function phi at the initial point. So in this particular problem, in order to evaluate the work done, there is no need to consider whether it is a semicircular path or whether it is a straight line or whether it is some other path joining 1, 0 and minus 1, 0. We need only to check whether the function is conservative or not. Here, since it is given that f is conservative, the particular work done will be nothing but the semicircular path C is from 1, 0 to minus 1, 0. So it will be phi of minus 1, 0 minus phi of 1, 0. This will be the work done. So phi of minus 1, 0 minus phi of 1, 0. But we have already obtained that this particular function phi of xy is equal to x e raised to y plus k. So we have phi of xy is equal to x e raised to y plus k. So this is equal to phi of minus 1, 0 minus phi of 1, 0. So this is equal to minus 1 into e raised to 0 plus k, that is phi of minus 1, 0 minus phi of 1, 0. Phi of 1, 0 is 1 into e raised to 0 plus k. So this is equal to minus 1 into e raised to 0, that is minus 1 plus k, minus k gets cancelled. The remaining is minus 1. So minus 1 is equal to minus 2. So this work done by this particular conservative field, vector field F on the particular particle to move from the point, we need only to consider the end point 1, 0 and minus 1, 0. It is phi of minus 1, 0 minus phi of 1, 0 and it is equal to minus 2. Hope that it is clear to you.